this is my example of an excitatory neuron circuit. So here at neuron 1, the excitatory neurotransmitter glutamate has already been released into the synapse here, and at this dendrite, it is going to be received by an AMPA receptor, which will cause a conformational change. So this is glutamate bound to this AMPA receptor, and at that point, this sodium-gated channel will open through conformational change and allow extracellular sodium, these green dots, into the cell to cause depolarization of the cell, which will bring the localized potential of the cell closer to 0. This voltage is summated at the axon hillock here through these voltage-gated sodium/potassium channels. So at this point, we can assume that we've reached a threshold of -55. So these voltage-gated ion channels will then open through the summation of EPSPs of these Na/sodium ions entering the cell, and they will allow even more sodium to enter the cell, and they will push potassium out of the cell to propagate the axon potential, which has been fired, down the axon. And once we reach the axon terminal over here, we have a calcium channel, which is also voltage activated through the propagation of these channels from the entry of sodium. So this is activated, and this will allow calcium to enter the cell, which will then signal for the membrane to fuse with the axon terminal, which will contain the next neurotransmitter glutamate to be fused into these vesicles and ready for release across the synapse. So at this point, we have released a bunch of GABA, which is inhibitory.